We often think of pandemics as fast-moving viruses. We imagine things like influenza or other new diseases sweeping across the globe. But there is another kind of global health crisis happening right now. It is unfolding slowly and quietly, in hospitals, on farms, and inside our own bodies. This is the crisis of antibiotic resistance. It's called a silent pandemic because it doesn't have a dramatic, sudden beginning. There is no single patient zero. Instead, it is a gradual erosion of one of modern medicine's greatest achievements. The drugs that have saved millions of lives are slowly but surely losing their power. Antibiotics are the foundation of so much of what we consider modern healthcare. They make surgeries like hip replacements and cesarean sections safe. They allow cancer patients with weakened immune systems to survive chemotherapy. They treat common but potentially deadly infections, from pneumonia to skin infections. For decades, we have taken these miracle drugs for granted. We expected them to work every single time. But that guarantee is now fading away. Every time we use an antibiotic, we are putting pressure on bacteria to evolve and find ways to survive the attack, making the drug less effective for the next person. The silence of this pandemic is precisely what makes it so dangerous. Unlike a new virus, antibiotic resistance builds up over many years. Its effects are not always immediately obvious. A patient might stay in the hospital a few days longer. A routine infection might require a second or third type of antibiotic to be treated successfully. These individual events seem small, but when you add them all up across the world, they represent a massive and growing threat to public health. We are quietly slipping back into a pre-antibiotic era, where a simple cut or a sore throat could once again become a life-threatening event for anyone. The scale of this problem is truly global, and its impact is already being felt everywhere. The World Health Organization has declared it one of the top 10 global public health threats facing humanity. Infections that were once easily cured are becoming harder and more expensive to treat. This silent creep of resistance means that the medical safety net we have all come to rely on is beginning to fray at the edges. Without effective antibiotics, we lose much more than just a cure for infections. We lose the ability to perform a huge range of medical procedures safely, fundamentally changing medicine as we know it today. To understand antibiotic resistance, we have to think about evolution on a very small and very fast scale. Bacteria are incredibly simple, but incredibly adaptable, living organisms. When you take an antibiotic, it is designed to kill harmful bacteria or stop them from multiplying. However, within any large population of bacteria, there will always be a few individuals that by pure chance have a natural genetic mutation. This tiny change in their DNA might make them slightly less vulnerable to the antibiotic. It's like having a slightly better shield in a battle where everyone else has a weak one. This is the starting point for resistance. When an antibiotic is introduced, it wipes out the vast majority of susceptible bacteria. This is a good thing, as it makes you feel better. But the few bacteria that happen to have that resistant gene survive the onslaught. With all their competition now gone, these tough survivors have the perfect environment to multiply rapidly. They pass their resistance gene on to all their offspring. In a very short time, you can go from having an infection with mostly treatable bacteria to one dominated by a new, resistant strain. This is natural selection happening right inside your body, and it happens incredibly fast because bacteria can reproduce every 20 minutes. Bacteria have another clever trick up their sleeves for sharing these survival tools. They can pass their resistance genes not just to their direct descendants, but also to other, unrelated bacteria around them. They do this through a process called horizontal gene transfer. It is almost like one bacterium handing a blueprint for a shield to another one, even if they are from a different bacterial species. This allows resistance to spread much more quickly and widely than if it only happened through reproduction. A single resistance gene that appears in one type of bacteria can soon be found in many others, making a whole range of different infections harder to treat. This process is a natural part of bacterial evolution. It has been happening for billions of years. However, our actions over the last century have dramatically accelerated it. Every time we use an antibiotic, we are creating a new opportunity for resistant bacteria to thrive and spread. We have essentially been running a massive, uncontrolled evolutionary experiment. The result is that we are now facing superbugs, bacteria that are resistant to multiple types of antibiotics. These are the formidable enemies at the heart of this silent pandemic, and they are a direct result of bacteria's remarkable ability to adapt and survive our best attacks. A huge part of the problem comes from how we use and misuse antibiotics in human healthcare. For years, it was common for doctors to prescribe antibiotics for viral infections, like the common cold or flu. The simple fact is that antibiotics have absolutely no effect on viruses. Giving them for a viral illness does nothing to help the patient get better. Instead, it needlessly exposes the vast communities of bacteria living in our bodies to the drug. This gives any resistant bacteria a chance to multiply and thrive without any medical benefit. It's like trying to put out a fire with water when the fire is electrical. It doesn't work and actually makes things much worse. Another major issue is patients not finishing their full course of antibiotics. We have all been there. You start to feel better after a few days of taking the medicine, so you think it's okay to stop. But feeling better doesn't mean all the harmful bacteria are gone. Taking only part of the prescription might kill off the weakest bacteria, but it leaves the stronger, more resilient ones behind. These tougher survivors can then multiply, and the infection can come back, this time in a form that is much harder to treat. Completing the full course as prescribed by your doctor is essential to ensure that all the harmful bacteria are wiped out completely. The problem extends far beyond our local clinics and hospitals. In many parts of the world, antibiotics are used on an industrial scale in agriculture. They are often given to healthy farm animals, like chickens, pigs, and cattle, not to treat sickness, but to promote faster growth or to prevent infections in crowded and often unsanitary living conditions. This constant low-dose exposure of antibiotics to vast numbers of animals creates a perfect breeding ground for resistant bacteria. These resistant bacteria can then be transferred from animals to humans through the food chain, on contaminated meat, or through the environment via farm runoff into water sources. This widespread use in farming accounts for a massive percentage of all antibiotic consumption globally. In some countries, more antibiotics are used in animals than in humans. This practice puts evolutionary pressure on bacteria in a huge environmental reservoir, allowing resistance to develop and spread far from a hospital setting. The resistant bacteria that emerge on farms do not stay there. They become part of a global ecosystem of microbes, contributing to the pool of resistance genes that can eventually find their way into pathogens that make humans sick. It's a classic example of a problem in one sector, creating a massive risk for another. The consequences of widespread antibiotic resistance are frightening to consider. We face a future where common infections could once again become deadly. Imagine a simple urinary tract infection that doesn't respond to any available drugs, leading to kidney failure and sepsis, or a child's scraped knee becoming infected with a superbug, requiring amputation to save their life. This is the reality that doctors in some parts of the world are already facing. Medical procedures that we rely on, such as organ transplants, joint replacements, and chemotherapy, could become too risky to perform because the danger of an untreatable post-operative infection would be too high. But this future is not inevitable. There are simple practical steps that we can all take to help turn the tide. As individuals, we must become better stewards of antibiotics. This means not demanding antibiotics from our doctors for viral illnesses like colds. It means trusting our healthcare provider when they say an antibiotic isn't needed. When we are prescribed antibiotics, we must take them exactly as directed and always complete the full course. Good hygiene, like regular hand washing, is also a powerful tool. It helps prevent infections from spreading in the first place, reducing the overall need for antibiotics for everyone in the community. Communities and governments also have a critical role to play. We need better surveillance to track the emergence and spread of resistant bacteria. Hospitals and clinics must enforce strong infection control programs to prevent superbugs from spreading between patients. There is also an urgent need to restrict the use of medically important antibiotics in agriculture, reserving them only for treating sick animals, not for growth promotion. Furthermore, we must invest in the research and development of new antibiotics, as well as alternative treatments, like vaccines and bacteriophages. The pipeline for new antibiotics has run worryingly dry in recent decades. Ultimately, tackling antibiotic resistance requires a united global effort. Bacteria do not recognize national borders. A resistant strain that emerges in one country can, and will, spread around the world in a matter of weeks, thanks to modern travel. Therefore, international cooperation is not just helpful, it is essential. We must work together to share data, coordinate policies, and invest in solutions. The silent pandemic of antibiotic resistance is one of the greatest challenges of our time, and the clock is ticking. Taking decisive action now is our only hope of preserving these precious medicines for our children and future generations.